Well, over here to the right, we do have the compound interest formula right here. And here's the explanation for each of the variables. Where n is the number of times the interest is compounded each year. So this is actually what we're trying to evaluate at different values for n. In other words, P is 9,200, our initial amount. The interest rate is 6%, written as a decimal is 0.06 per year, over n, which is the number of times the interest is compounded each year. And this is T, which is 15 years. That's constant in all of these problems, or all of these situations. And n is, again, the number of times the interest is compounded each year. So we want to let n equal 1, 2, 4, 12, 52 as if the interest is compounded weekly, and 365 days in a year compounded daily. Well, I don't know about you, but I don't want to go to the trouble of putting 1 in for n, 2 in for n, 6 different numbers for n. I'd rather use a calculator. And here's one way to do it on Desmos. Here's the function definition, just based or depending on n. And here I've set up a table with the different values of n that we want to look up. And so there's your answers right there. We could round those to the nearest cent, which is probably what the expectation is. And over here you can see the graph of this function and the 6 points at which we've calculated the amount left after a given number of years. There you go. And if you have any questions, post a comment.